Hey everyone, thanks for tuning in. Today we're going to be looking at the distance between 2 points. Okay, so I'm going to be looking at how we actually derive the formula of the distance between 2 points and look at three various examples in different sort of scenarios involving the formula. Okay, so let's begin with actually how we get the formula. Okay, so we're looking at the distance between 2 points. So I'm going to start off by picking 2 points on this axis. All right, this point here, which I'm just going to label x1, y1, basically meaning it can just be any coordinate. And I'm going to pick another one, let's say here, which is going to be called x2, which is going to have the coordinates x2, y2. Yet again, which means just any point that's just different to this one. Okay, so it could be over here, it could be way over here, down there, anywhere. Okay. So this is just the general formula for any sort of case that we might come up with. And what we're looking at when we're considering the distance, we're looking at how long is this blue line here. Okay, so how long is that distance? And to get the formula, what we need to do is construct a right angle triangle. Okay, and so we do so. And we're constructing a right angle triangle like so, where the right angle is at this point over here. Okay, that's the right angle over there. And we're going to be using Pythagoras theorem because we want to find this distance here. Okay, and if we have this distance over here and this distance here, then we can find Pythagoras theorem. We can find this length by Pythagoras theorem. So the question is, well, what is that length and what's this length? And this length over here, right, the vertical length of this triangle is equal to y2 minus y1. And how we get this is we consider from the distance from 0 to y2, and that's like all of that distance over here, okay, from the x-axis up until the point, and we're subtracting it from 0 to y1, okay, so we're taking this whole distance here and subtracting it by this small distance here, and what we're left with is this vertical line here. Okay, and by a similar argument, the horizontal length of this triangle is going to be equal to x2 minus x1. Okay, and I'm just going to say that this distance here is going to be d. Okay, and if we recall Pythagoras theorem states that c squared is equal to a squared plus b squared, where c is the hypotenuse and a and b are the other sides of the right angle triangle. So c, which is our hypotenuse, in this example up here is this d. Okay, and my other sides a and b are going to be y2 minus y1 and x2 minus x1 in no particular order. So if we apply this, we get d squared is equal to, now a, I'm going to call x2 minus x1, so it's going to be x2 minus x1 all squared, so squared, plus y2 minus y1, and that's for the b, okay, and that's all squared. Now if we just want the distance, because at the moment we've got the distance squared, and if we want the distance, then it's going to be just the square root of all of this. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And that's basically the distance between 2 points given coordinates x2, y2 and x1, y1. Okay? So let's look at a few examples. So we're going to start off easy with the most basic example you can get, which is just find the length of the interval between 2 points. Okay, so we want to find the length of the interval AB, where we have point A is -2,7 and point B is 3, -5. Okay, using our formula, which says that the distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's just say this 3, 5 is our x2, y2, and this negative 2, 7 is our x1, y1. So that means D is equal to the square root of x2 minus x1, which is 3 minus minus 2. Okay, 3 minus minus 2, okay, squared, plus y2 minus y1, which is going to be negative 5 minus 7. So negative 5 minus 7, all squared, okay? So our distance is just equal to root of 3 minus minus 2 is 5 squared, plus negative 5 minus 7 is negative 12 squared, and that gets us to root of 25 plus 144, which gets us to the square root of 169, which is just equal to 13. So our distance between these 2 points A and B over here is 13. Okay? So that's the most simple example that you can kind of get for these types of questions. The next example we're going to be looking at is this one here, which says explain why the triangle ABC is isosceles, where we have A is this point here, B is that point here, and C is that point here. Okay. Now, if we remember what an isosceles triangle is, it's a triangle where two sides are equal. Okay. So we can have some sort of triangle here, and what it'll be is that like these two sides here are equal, and these two angles over here are equal. This side over here can also be equal, but it doesn't need to be for it to be like isosceles triangle. If this side is in fact equal to the other two, then it will just be an equilateral triangle. Okay, which is another form of isosceles. So let's actually consider the formula of like distance between 2 points, because at the moment we've got a point A, we've got a point B, and we've got a point C. Okay, and we don't know which sides is equal to which. Okay, so what we're going to do is just find the length of each side. We're going to find the length of AB, length of AC, and BC, and hopefully two of them are equal. Okay, so let me start with the length of AB. And so the length of AB is equal to the square root. Now I'm considering these 2 points here. So it's going to be x2 minus x1, which is going to be 1 minus minus 4, which I'm just going to say is 5 squared, plus negative 2 minus 2, which is negative 4 squared. Okay, and that's equal to the square root of 25 plus 16, which is equal to the square root of 41. So we have the distance AB is equal to the square root of 41. So let's now consider the distance BC. Now BC is equal to the square root of, yet again, x2 minus x1. So we're considering BC, so these 2 points here. Okay, so x2 minus x1 is going to be minus 4 minus 5, which is going to be negative 9 squared. Then y2 minus y1 is 2 minus minus 7, which is 2 plus 7, which is 9 squared. And that's just going to be equal to the square root of 81 plus 81, which is equal to, it's going to be equal to 162, okay, which is not square root of 41. So that doesn't make too much of a difference because we've got one more side that we need to test. This just indicates to us that it's not going to be an equilateral triangle. And then the final thing we got to consider is the length AC. Okay, so AC is equal to the square root of x2 minus x1, and we're considering A and C, so it's going to be 1 minus 5, which is negative 4. Okay, negative 4 squared, plus y2 minus y1, which is negative 2 minus minus 7, which is negative 2 plus 7, which is 5 squared, and that's going to be equal to the square root of 16 plus 25, which is the square root of 41. And what we notice is that the side AC is equal to the side AB. So we say, therefore, we can actually say which equals AB over here, and then make a statement. Therefore, since AB equals AC, since AB equals AC, triangle BC is isosceles. Okay, and that should be enough to get you the full marks. Okay. Now the final example we've got going on is find the values of A when the distance between these 2 points, A -1 and 4 -3. So when that distance is root 29, what are the values of A? Okay, so we're giving it the distance and we need to find a coordinate. Okay. Now there's going to be 2 possible values for this coordinate, and the reason why is because if I just do a quick sketch, okay, we have the point, this point here, which is fixed, which is going to be 4 -3, so that's like roughly about here, right? 4 -3. And we've got this point here, which is going to be A -1, which has, so it has a y coordinate of -1, which is going to be down here, and has an x coordinate of A, so it can be anywhere along this line. Okay, so it can be anywhere along this line where that has a coordinate of -1. Okay, and it's important to realize that this coordinate of A could be 2 values, because what distance has root 29? Okay, sorry, what point between, sorry, what value of A can you make where the distance between these 2 points is root 29? And what you can hopefully see is that, let's say this distance over here happened to be root 29. Okay, well, by a similar argument you can extend out the other way, right, by such a, you know, such an angle that you can make root 29 also equal to, you know, this distance here. Okay, and what we can see is now that we've got 2 values of A. So we can have this value of A here, or we can have this value of A here. Okay, so we can have both. So we're gonna, moral of the story is that we're gonna have 2 values of A. So let's actually get cracking in the question. So we've got these 2 points here, and we're saying the distance between them is root 29. Remember the formula, okay, which says D, so which is root 29, is equal to the square root of x2 minus x1, which is going to be 4 minus a, so 4 minus a all squared, plus y2 minus y1, which is -3 minus 1, and that's going to be -3 plus 1, which is -2 squared. Okay, so once we've got this, it's literally just a equation that we need to solve for a. Okay, so I'm going to square root. I'm going to square both sides to cancel out that square root, and I get 29 is equal to 4 minus a squared plus -2 squared is, I'm just going to write it as 4. Okay, and I'm going to subtract 4 from both sides, and in doing so I'm going to get 25 equals 4 minus a squared. Okay, just making it look a bit nicer, just switching it around. 4 minus a squared equals 25, and I'm going to square root both sides to get rid of this square over here, and 4 minus a is equal to 5. However, because I square root, remember I can get 2 values. I can get a positive or a negative value. So I got to consider the 2 cases where so the first case is where 4 minus a is equal to positive 5. The second case is where 4 minus a is equal to negative 5. Okay, and in this case here, it's just going to be a is equal to -1, and in this case here, a is equal to 9. Okay, so yeah, so as we can see, we've got 2 values of a which both produce a distance of root 29. Okay, so in this case here, my drawing was a little bit inaccurate, so the value of a should have been here, and the other value of a maybe a little bit over here. Okay, so moral of the story is that there were 2 values of a, and we found those values. A very common mistake is that when we square root over here, we don't consider the positive and negative case, we just consider the positive case. So that's about it for the distance between 2 points. Okay, I hope you guys learned something useful, and I hope it helped. Good luck with your studies, and I'll leave you with that.